Hi there, and welcome to the Mat 211 review on partial derivatives. My name is Julia, and I work for the tutoring centers at ASU. So for our problem today, we are going to look at finding the partial derivatives with respect to x and with respect to y of our function f of xy equals 2x e to the 7xy. And then we're going to evaluate both of these at the point 1, -1. So let's start with our partial of f with respect to x. So if we write that down here, partial of f with respect to x, and if we want to write that explicitly, the partial with respect to x of 2x e to the 7xy. Now, the thing to notice here, we're evaluating this with respect to x, and there's actually two functions here with respect to x. We have a 2x here, and we have an e to the 7xy here. Now, because we have two separate functions, this is going to be an instance where we need to use the product rule in order to take our derivative. So just as a reminder, the product rule is, so suppose that we have two functions, g of x times h of x. Doesn't matter what they are. If we go ahead and take the derivative of that, that is going to equal g prime times h, just the regular function h of x, plus the regular function g times h prime. So the derivative of h. So with that in mind, we're going to treat 2x here as our first function, and e to the 7xy is our second function. You could also include the 7 with your e term here. It doesn't, or excuse me, the 2 with the e term here. It doesn't really matter, but I prefer to keep it along with the x. So let's start by taking the derivative of this first function here. So that's going to be 2. So the derivative of 2x is just 2. And then we're going to times it by just the regular function here, e to the 7xy. And we're going to add to that the regular function here, 2x, times the derivative of e to the 7xy. So since this is an e function, or an exponent of e, we're going to have e to the 7xy, but then this becomes a chain rule because we have this 7xy here, so we then have to take the derivative of 7xy, and the derivative of 7xy with respect to x is going to be 7y. So now we can just gather our terms here, make this a little nicer to look at. That gives us 2e to the 7xy plus 14xy, I just brought the y and the 7 to the front here and multiplied them in, e 7xy. Yay! All right, so that is our derivative of f, partial derivative of f with respect to x. Now we can go ahead and evaluate the partial with respect to x at our point 1, -1. And this just involves putting a 1 in place of every x and a -1 in place of every y for our derivative here. So this gives us 2e to the 7 times 1 for x times -1 for y plus 14 times 1 for x times -1 for y times e to the 7, 1, -1. And if we go through and simplify this a little bit, multiplying these together, this gives us 2e to the -7 plus, actually minus, because we've got that negative being multiplied by our 14 here. So we've got minus 14 e to the -7 again. And we can simplify this further by just subtracting this term from this term, and that gives us -12 e to the -7. Great. So now that we've taken care of finding our partial with respect to x and evaluating it at our point, let's go ahead and do our partial with respect to y. And I'm going to go ahead and erase my product rule here just to make myself some more space. Maybe clean this up too because this is a mess. All right, so we've got our partial of f with respect to y. And we can write this out more explicitly. All right. So in this case, because we're evaluating with respect to y, remember we're going to treat all of our x terms as just constants. So we only have one function here with respect to y, because that's the only place that we see our y showing up. So all of the rest of this, we can just treat, this guy and these guys here, we can just treat all of that as constants with respect to our partial with respect to y. So if we do the math on this, we've got our 2x in the front here because it's a constant that is multiplied in, times our e to the 7xy. But again, remember that this is going to be a chain rule because this is not just a simple y term. So we're going to take the derivative of 7xy with respect to y, and that will give us 7x because the y goes away because the derivative of y is 1. And then again, we can go through and just clean this up a little bit. We'll bring these guys to the front and multiply them by our 2x. So that gives us 14x squared times e to the 7xy. So that is our partial derivative with respect to y. Now again, we just evaluate at our point 1, -1. By subbing our values for 1 and -1 here. So that gives us 14 times 1 squared for our x times e to the 7 times 1 times -1. And if we multiply this out, we find that we have 14e to the -7 as our final answer. So there's that. Great, and that's all there is to it. So before I go, I just want to remind you all that if you would like to access any additional tutoring or academic support at ASU, you can go to tutoring.asu.edu. You can use the tutor search function, which can be accessed both at our main webpage as well as this explicit link here, the full link. To use this, it'll allow you to find tutoring services for a specific course. So if you need help with a specific course, you can search and find what sorts of resources we have for that specific course and that specific day and time. So thank you so much and have a great rest of your day.